Okay, now we're going to move on to section 1.3, objective number 5, which is solving percent problems. So just like with the previous video, pause the video, try the problem on your own, come back to the video, check your work by watching me work through the problem and see if your answer matches. Watch the video a few times if you have to. This is the best way for you to definitely make sure you understand what we are going over now with applied problems. So since we're talking about percent problems now, we're going to be moving into discussion of percent. Now, on this lecture slides, you have the steps of how to convert from a decimal to a percent and a percent to a decimal. So I'm not going to go over that here in the video. So let's go straight to page 84 of the text and look at question number 39. Okay, so 39 says, in 1995, the average cost of tuition and fees at public four-year universities in the United States was $28.11 for full-time students. By 2009, it had risen approximately 150%. To the nearest dollar, what was the approximate cost in 2009? Okay, so it was given in 1995 that the cost of tuition and fees was $28.11. And that 2009, it had risen 150%. So we are now going to solve for, in the end, the 2009 tuition. That's what the question is looking for. Not how much it rose by, but what the actual tuition was in 2009. Okay, so for us to find that, we're going to take the value that is the tuition in 1995, and we're going to multiply that by 150%. But when we multiply by percentages, we have to convert to a decimal. So we go to our percent, we drop the percent sign, and we move the decimal point 2 places to the left. So 1, 2. So 150% would be 1.50. And this is going to equal how much the tuition rose by. Not the total tuition, but how much it rose by. So I take these numbers, I put it into my calculator, 2811 times 1.50, and I get a value of 4216.5. So 2811 times 1.50, I get a value of $4,216.5. Okay, that's how much it rose by. The question is, what is the actual tuition in 2009 now? So I have to take this amount and add it to 2811. So 2811 plus 4216.5. Again, I typed it into my calculator. I get a dollar amount of $7,027.5. The question says to the nearest dollar. So the 7, I have to round to the nearest dollar. So in the end, the tuition 2009 was $2,028, which is the answer you see on your slides. Now our next problem, still found on page 84, is question number 43. Okay, so 43 says, at the end of a day, Eric Bergen found that the total cash register receipts at the motel where he works amounted to $2,725. This included a 9% sales tax charge. Find the amount of the tax. Now we have a total here. We don't have the individual amounts. Before we had the individual amounts, we were asked to find the total. We're kind of working backwards now. So in this case, I have to kind of create a little bit of an equation. And I have to think, how do I solve for a total when I'm given a dollar amount and a sales tax amount? So let's say X is our total amount of our total sales. Sales tax would be that amount times the actual sales tax rate. When you add those two values together, you get the total, which is in the question total sales of $27.25. This is the part we're solving for. What is the sales tax? But we can't find sales tax if we don't know total sales. So let's rewrite this problem. So it's really going to be x plus 9% is really 0.09x equals 27.25. So x times 9% is rewritten as 0.09x. This is really a 1x. So 1x plus 0.09x gives us 1.09x equals 27.25. Divide by both sides by 1.09. And I get my x value to be 2,500. Now remember, x is up here. This is total sales. And you always determine sales tax from your total sales. Well, sales tax is 9%. So I'm looking for 9% of 2,500. So now let's do this math. So 0.09 times 2,500. Remember, of means multiply. Multiply these two values together. And I get 225. This is how much of the sales is actually sales tax. And of course, you can check your work. 2,500 plus 225 does give me the total amount that's in his drawer at 27.25. So this concludes the examples for section 1.3, objective number 5, using percent problems. Please review the other videos posted for section 1.3. If you are still confused on how to translate your expressions and equations that we will be doing for the remainder of our word problems. Thank you.